We are still together, right?
Yeah.
Okay. So you get to your session layer, and then the next thing is your presentation layer. Of course, your presentation layer is your layer C. So what is presentation layer? Presentation layer talks about
I think we stop at the transport layer.
transport. I was already talking about session.
Oh, okay.
Yeah, I said session layer is like your train, how they go, you know.
Okay.
Transport is the mode that they are going. The session is how they go, right?
Okay.
So
Mode.
this could be in batches and the rest of them.
Okay.
Okay. Let me give you a practical example. How many of you've tried to, because these are all things we do, you've tried to make, especially those of us who use cyber cafe in those days. If you visited, if you're as young as me and visited cyber cafe those days, you notice that when you go to cyber cafe, you buy 60 minutes. Sometimes it's when you are about finishing high and your money has finished. You now remember something you need to download to save inside your flash drive. Somebody is laughing at me. You remember, and then you start downloading the thing. And then somehow halfway the thing will cut, your time will finish. How many of you it has happened to you?
Yeah, it has happened, sir.
It has happened a lot of times.
It happened. And then you notice that even though that thing was 90%, at least the thing should open, especially if it's a movie, right? You notice the whole movie did not open. Are you guys following me this evening? I'm trying to interact. I'm trying
you're
to
following
interact
up.
because security is something you're going to solve. People will expect you to interact and you need to understand it. All right. So the reason I'm saying that is because you can download something 99%. If the thing is like a document, for instance, maybe a PDF or a Word document, you notice that the thing will not even open at all until you have downloaded it for 100%. It gets to 100%. Whereas there are things like audio, you are downloading it, it gets to 60%, you had a network failure and all that. You still take that one, you notice that that's few that downloaded will play halfway. Right? So I'm getting feedback. All right. So you notice that how they are transported, how the different data, how different data types are transported is different. So their transportation mode may be different. So that's why when they create a session, there's how they relate in a session. And that's where you hear things like TCP. How many of you have heard of TCP? All of you should have TCP/IP.
Yes.
Yeah, you hear things like TCP/IP, So your IP address is actually works with that protocol, transmission control protocol. So the internet protocol. So when I say send me your IP address, that thing I'm just saying I want to be able to talk to you at this level with this mode of communication. All right. So, and then we talk about your presentation layer. So what is presentation layer? Presentation layer is how that data, so this is now towards the receiving end. So the presentation layer is how the thing is packaged and, pushed back to the application layer. Now, the application layer, for instance, let's assume from the physical layer, what I was sending was an email. That was the example I was using. So if I send an email here, the application layer, which is the receiving end, what is the application you will use to receive an email? Who can give me one?
Yahoo.com, Gmail.
Exactly. So I need a Gmail. It's an application, right? It's a web application, different type of application. You have it running, and then you can receive that email I sent to you. Okay. Now, you've heard of some, I don't want to call names, but somebody that they said, they actually attacked, they saw how many emails that she sent, he sent. I'm not calling anybody's name, all right? But you see, where did those people know that that madam or that man actually sent those emails? They were able to do something within this level. All right. Are we all following?
Yes.
All right. So there's something, and then it takes me to what I want to talk about now. Now, there's what we call SSL. Now, SSL is actually called Secure Socket Layer, right? It's a communication protocol, all right, or a set of rules, that is applied between two devices, okay, or applications on a network. For instance, even though technically we say this, that layers, the 7 layers of communication, OSI model communication, goes from layer 1 to layer 7, okay? Somehow these things work in reverse order as well, in the sense that your physical layer is also present here. Now, that application is also running on, for instance, this person receiving the application, the receiver is also receiving it on a physical device. True or false?
True.
Right? The person sending that email is also sending it using an application on. So you see, this thing is intertwined, but we like to see it in the terms of communication. We try to just separate it, but at the back of your mind, you notice that these things go hand in hand. Now, if you try to reverse it, here's what you're going to notice. This is going to be 7. You're going to have 6 here. You're going to have what here? 5 here, right? You're going to have 4 back here, and then you have what here? 3 here. Are you getting it?
Yes.
I'm going to take it again. If you reverse this thing, because here we are going to, transmit data and then receive data. So this is how it goes. Now, we say this thing overlaps somehow. So what it means is that if you try to reverse this thing, and there's a reason I want to show us that, if you try to reverse this thing, this application layer is also present in the physical, right? Okay. Then you have, so if you reverse this thing, put 1, put 7, put 2, put 6, put 3, put 5, put 4, put 4, put 5, put 3, 6, 2, 7, 1. Right? Now, if you do that, no, that's just a funny way, but in my head, that has been one way I learned how to troubleshoot and know where issues are happening very fast. So it means that anything that has to do with network, because networking is something very, very deep. Of course, the internet is, and it's a networking of computers. It means that quite a lot of time, most of the times, the issue you are going to be having would be between layer 5 and layer 3. Are you getting it? So the internet protocol, all those type of things, those issues are going to be happening around here. And for you to be able to track them, so anybody that is, hacking and doing all those kind of malicious things, this is where their interest is in. The guys that try to do things on the application layer or application level, those ones are just social engineering. Those ones are Yahoo. They are not really hackers. They are just trying to, they are not really, what hackers do is, this is where they play. You know, they want to get into your network. They can sit in your router and be getting everything happening there, you know. And so when we talk about SSL now focus on how do we now, you know what, because the road to this guy is through these guys and this guy. So it's either the application or the physical device. So what we do with SSL is now we create a protocol that these guys will recognize. You get it? So we create that protocol, and that's what I think Cheesy was talking about earlier. You know, it's scrambled. So we scramble that thing. So I want to send you an email. I want to send you this guy sitting here an email. Okay? Now, from here, how do I do it to ensure that if I send it, that this guy will understand it? Okay. Number one means that I need to first of all send something from here up to that level for him to actually understand. But you see, if we do that communication, this guy needs to tell me that, oh, yes, I know you. That's going to take us a lot of time. So if you flip your mind back to that thing I said, that intercommunication, both of them will meet in between. Now, that place where they are meeting is actually between these layers. Now, when they meet there, what happens is that they exchange to themselves some cryptographic writings, something you call a message, and that's what we call the TCP handshake.
Okay. TCP handshake.
All right. Now, the TCP handshake. So if you understand this, you understand security. So any type of security architecture you want to apply, you know, it's either you are building on top of this or you're making it more robust, or you're trying to, you know, whatever way you do it. So if you go, I'm going to open one of them up. So this is what happens. The three things actually happens. Now, let me see one that makes it very, very simple. All right, so let's look at this one. So we want to create a secure connection. All right, before we start communicating, so because this is what SSL talks about, this is what it's all about. Before we start communicating, before we start sending all those emails, those heavy, you know, love letter in between ourselves, we want to make sure nobody's hearing. Okay, so what happens is that the client, what we call client now is, take it like your physical layer. Keep your mind on this thing. This is where the communication begins, right? Remember, I told you this guy and this guy is embedded, but just think about it that the communication starts from P, your physical layer, right? So what happens is that I'm going to call him the client. That's the sender, right? Now, this sender, he wants to send something to this guy here, but he doesn't need to really travel over to this guy here, because this guy doesn't really have any protocol that will guarantee that both of them will actually communicate safely. What happens, because two of them are communicating over a server, meaning they are communicating to some kind of central point. All right. What happens is that this guy sends what we call a sync, what we call a server hello. Now, when he sends that request, okay, what happens is that the server now responds. You know, he gives him something like a token. Okay, he gives him something like a token. There's this what's it called? Is it byte key? You know, there's this type of key technology where I have half of the key, you also have half of the key. Okay? Two of us need that key to be able to unlock stuff. All right? One of us will not be able to unlock it. So that's what happens here. So the client sends a message and say, hey, I actually need something. I want to talk to you. Sends him an hello, you know, a sync, and then he responds and say, okay, I acknowledge you. He sends a synchronization and then an acknowledgement. And then once the client acknowledges that, sorry, okay, so once the client, you know, the server sends that sync plus ACK, that's acknowledge, then what happens? If you look at the sequence here, the sender sends something like M, for instance, server receives the M, right? And then what server now sends, he now sends N back, which is his own key now. Are you getting it? He now also sends an acknowledgement message back to him. All right. Now, what this guy will now receive, he now got that sync and say, okay, so that sync is like, okay, yeah, I'm ready for you. Send me whatever you want to send. Then this client guy will now say, oh, I recognize this is N. This is N is matching with my M. All right. So what will happen? He sends an acknowledgement. And then once he acknowledges, what happens that once this thing completes, guys, pay attention. Once this three-way handshake completes, what happens is that they create a session. Now, once they create a session, every other communication to the application layer happens securely. Are you getting it? And that's why if you leave, stand up now and walk away after 2 hours or after maybe 30 minutes, you come back and then you try to do it again, the thing tells you session time out or whatever this thing. That thing, what is actually causing it is what we call TTL. Now, what is TTL? TTL means time to leave. It is the amount of time or hops that a packet is set to exist inside a network before being discarded by a router. So once two of us have established that connection, both of us have what we call our TTL. That's the time to leave. It means that, you know, because hackers are going to keep trying and all of that. Now, apart from that, if two of us, again, it's also a wise way to use your network, because if two of us now stop sending message, but we still, you know, we did not break the connection, you know, which is what some people do sometimes. We did not break the connection. These two guys will still be waiting, but data is not being sent in between. So they are just there waiting. Are you sending? Are you not sending? Do you send? Do you not send? Two of them wait. They will just wait up to their TTL, their time to leave. And once they are done, they break that connection. So if somebody comes after that time, because this is where hackers actually come in, because imagine there's no TTL and we have our connection established and we are not exchanging data. Somebody can now sneak in, if possible, if person has the keys and all of that, you know, and then go back and of course be able to retrieve whatever has happened, blah, 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 inside of us. So these are some of the measures. So this is largely being done. So this is what causes this thing, or what how we are able to achieve this thing, you know, within in a network setting, is what we call SSL, right? SSL, which is Secure Socket Layer. It's a security protocol that provides privacy, authentication, and integration to internet communications, right? Even though SSL, of course, has evolved to TLS. The reason is simple. If you look at this thing, there are a couple of things. SSL, if you look at it, some people want to think that it's focused around just the session, but TLS is now like what it transitioned to, which talks more about it encompasses, the entire protocol between 3, 4, and 5. So both the network, the transport layer, and the session layer. All right. Does that make sense?
Yes, sir. Yes, sir.
Any questions? Any question before I talk about certificate authority?
No question.
All right. So now you have this SSL, all right, this certificate or the TLS, that we want to actually use to secure our communication between the client and the server. Now, what happens is that there are people. Now, you need to know that when we talk about the server, you are not the one who is like, imagine you want to buy something from, of course, the internet is a communication of servers, computers scattered all over the world, right? So when you for instance, let me clear my screen. Let me do something. All right, so let's assume I do NS lookup.
Sorry, Chris. What's the meaning of SSL? SSL.
Secure socket layer.
Oh, okay. You have said it. Okay.
So let's assume I do NS lookup of google.com, for instance. All right. So this is the server that Google is using to actually. So this is the server. This is the IP address on the server. That is giving me google.com. If you do an NS lookup from where you are, for instance, you also notice that the address that you get from google.com is different. Are you getting it? Can somebody try? Just do an NS lookup of that from your end. You notice something. NS lookup of google.com. Let me do youtube.com. Who is getting the same IP address that I'm getting? Is there anybody getting the same address? Ebenezer, what did you get?
I'm still opening my own.
Okay, so open. Everybody open. So this is the address Chris is getting. I'll post my own. Yeah.
Mine is different.
Huh?
Mine is different.
What did you get?
192.168.0.1.
So call it, post it in the chat. Let me see.
Okay.
Who else has checked?
Aye.
Right. Okay. So
Same
this
address.
So who got the same?
Kenny.
Kenny. Okay, you got the same as who?
192.168.0.1.
Can you know why you're getting the same?
Same location.
Exactly.
Yes.
Both of you are coming from the same region. So it's routing you to that So I'm going to try to browse to that IP, for instance. You see, it's not taking me to that because it's trying to, like, why are you going for? Because that server is very far from me. And that's why when those of you who travel around, you notice that when you open google.com, it tries to route you. It looks like, especially YouTube, in fact, YouTube will open the country where you are and show you that country at the top, right? It will put something like this, for instance. You see, mine is showing that I'm in this region, for instance. So wherever you are, it will try to send you to the nearest, Mark, can you check your audio? It should be from your end. Maybe you log out and log in, log back in again. Somebody can help type that for her. All right. So now, why that is happening, the point is this, that the server that they are using to host or respond to you is, is not managed by you. That's actually what I'm trying to get at here. So what needs to happen is this, all right? What needs to happen for that communication to be secure, all right? There are people we call certificate authority, all right? Certificate authority, they call them CA. Now, a CA is a trusted entity that ensures SSL certificates. So I now want to, I'm building a website or an application and all of that are finished. The only way I can expose it is by using HTTP. If I want to make it HTTPS and be able to communicate, or I want people to be able to communicate with me via HTTPS, which is a secured layer, I need to get that certificate from, and that's where the person that was actually reminding us about that certificate authority, you need to get one from a certificate authority. Why? Because they're the ones that, first of all, they take your identity and then they validate that this identity is true. And then what they do is that they split that thing across those authoritative servers, what we call authoritative servers. For instance, you see google.com routed you to 19, another person to this. It's routed me to, 6219. It could route another person. So imagine you who is just creating a simple application. You will not be able to create a certificate if you don't want to use a certificate authority and you decide to go for what we call self-signed certificate. So if you go for a self-signed certificate, this is where, how many of you try to browse something and then it shows you something like this? Your connection is not private.
Yes.
You see this, right? Now,
Yeah.
this is because the person here has, and then sometimes you notice the thing is even saying HTTPS, but it's still showing this thing. The reason is because that person is using a certificate that is self-signed. So you can see here, it's telling you attackers might be trying to steal your information from what? From self-signed certificate. And then if you decide to advance, it's just telling you that even though this thing is telling you is SSL, it's not really SSL, it's actually SSA. Okay, it's not really SSL because that certificate is not from a trusted certificate provider. So one way to actually use SSL and use it correctly is to make sure that you buy them from a certificate authority. All right. So there are quite a number of them. You have guys like Commodore, and these are top security companies, Cloudflare and a few of them like that. So you buy those certificates and then you add them to your connection. And what happens is people are able to interact with your application on, using those cryptographic link, and communication is secure end to end. All right. So that's basically that on SSL. I wanted to touch on that aspect of security because I noticed we've not talked about it and how you can attach it. So almost everything you do, in the cloud, you need to secure it, right? You need to secure it. If you create virtual machines, if you need people to interact with that virtual machines using HTTP, then you need to put a certificate, host a certificate inside of that machine to ensure that communication is actually secure. Otherwise, you just create a loose end for malicious people and other kinds of attackers to actually be able to, compromise what you actually have there. All right.
Chris,
So
can I ask a question?
Yeah, sure, go for it. So it's question time now, actually.
Okay, is this related to, there are sometimes you see some companies who now come and put up publication that they have gotten social certification from social organization and
So
concerning
those is
products.
ISO. Those ones is
Yeah.
ISO standardization. Well,
Oh.
our own is OSI.
Oh, okay.
ISO is the International Organization for Standardization. So when people are practicing, they give them this type of, so these are global standards. So any industry you are in, that's ISO, but our own is OSI.
Oh,
right?
okay.
Yeah, it's OSI. It's just it's a computing this thing.
Sorry, Chris, is there any difference between the two?
Yeah, of course. This one is ISO. This one, those of you who work in the oil and gas and the rest of them, you see this one, and that health safety organization. If your organization has to do it, safety, you see they need to put their standard. They need to say we are now certified these and all that. There are different standards. So depending on what the organization is doing, they need to meet a certain standard. All right. Why OSI? I've forgotten what's the meaning of is it open? What's the full meaning? Open systems interconnection. It was just a standard that were built. This one was built by engineers to describe what happens between communication of any two devices in a network. Whether it's computers, whether it's any two network, whether it's telephone. Telephone now. One telephone to another telephone is the same thing. This thing is the same across across two devices within a network. Whether it's server to server, whether it's user to client to server, whatever it is, this is the standard. This is what goes on inside. So this is basically how data is exchanged between two devices. So if that person that sent you, for instance, that person that sent you that love picture, or send you a picture, or even somebody is doing what do you call it? What is this thing? Is it airdrop? Yeah, iPhone airdrop, eh? Yeah. When somebody sends you an
airdrop, yeah.
Yeah, once somebody sends you airdrop, these 7 things is what is taking place.
But the possibility of airdrop being intercepted is so high.
Yeah, the point is, anytime you see, even you who is pressing a button with your remote and your TV is obeying it, that communication, these 7 things is happening.
Okay.
Do you understand? This is just a standard between any two devices communicating. You're sending something, somebody is responding. All right. So how they prove that the device understood what you sent is that it acts accordingly. So if you tell your TV to shut down, it shuts down. If you're using a wrong remote, if you press shut down and then it now changes channel, you know there's problem. You know, so this is actually the so there's a difference. I'm not sure if that is clear.
That's okay, thank you.
All right. Any questions? Any other question?
My next question would be, I joined class lately. I saw later I had Lincoln's